Hi, welcome to our session on what's new in Android development tools. I'm Jamal, a product manager on the Android Studio team, and with me I have Tor, the engineering director on Studio as well. We're excited to share some of the latest updates to Android Studio. We strive to make your lives easier by delivering a high-quality IDE that works with the latest Android APIs and Android features. On top of that, we'd love to hear your feedback to make sure we're working on things that matter to you the most. Today, we're going to talk about a range of things, from the latest stable to some bleeding-edge features. OK, let's get started with a quick update roadmap of where we've been. At I/O last year, we launched Android Studio 3.2, which had support for App Bundle, Navigation Editor, and Emulator snapshots, and a new energy profile that allows you to understand how your app impacts the battery on the device. Earlier this year, we launched Android Studio 3.3, and this included in-product feedback and single variant sync, which improves the speeds of sync speeds in the IDE. And just a few days ago, we launched Android Studio 3.4, which included a new resource manager, an updated project structure dialog box, and a shift to R8 as the default app shrinker. And in case you missed any of these updates, stay tuned for a demo at the end of the session for these features in action. And lastly, that brings us to Studio 3.5. So to walk us through what's inside of Android Studio 3.5, I'll give it over to Tor to walk us through it.
All right. Morning, everyone. So most years, I get to stand in front of you and play Santa Claus. I give a 25-minute demo of all the cool new features and surprises the team has built over the last year. This year is going to be a bit different. I don't have any new features to show you, and that's because we've been busy addressing your top complaints. So what I'm going to do today is tell you what we did. And I think as engineers, you'll find it interesting, but I'm hoping that as users, you'll be really excited, maybe even as excited as if I showed the new feature, because you'll see how your daily usage of the IDE will improve. So, all right, great. So to set the context, we announced Project Marble back in November. And since then, the entire engineering team has been focusing exclusively on fixing top issues that impact users. So we can divide that work into 3 buckets: system health, feature polish, and addressing the bug backlog. So let's start with system health. So by that I mean, how responsive is the UI, or are there any memory leaks? So the first thing we did was to beef up our analytics. The first time you run Android Studio, we ask you if you're willing to send usage statistics to us. Now, as you'll see, this is how we measure our system health. It's how we're measuring whether Project Marble is having an impact, and it's also how we're going to basically make sure that after Project Marble ends, we're going to hold the bar really high. And last but not least, we used analytics to report problems to ourselves. So, for example, if Android Studio throws an exception, if you've opted into analytics, we will send that exception up to our server, and then we have a dashboard where we can aggregate all these exceptions, sort them, such that we not only fix the most important issues, but we can also spot if there's a problem in a rollout of a new canary. So another issue with exceptions, let's say you're in your editor coding away, having a good time, and suddenly there's this little blinky light in the bottom right corner, drawing your attention away. If you've been using Android Studio, I'm sure you've encountered this. Well, because of our automated crash reporting, we don't actually need to distract you from your coding task to send that report to us. We already have it. So from now on, we no longer do. These are just silently logged, except for one class of problems, right? And those are foreground actions. So as an example, let's say that a toolbar action is broken. If you were clicking on it and clicking and nothing was happening, you'd be very frustrated, right? So foreground actions we continue to show, but we no longer blink. So the exceptions should be much less demanding of your attention from now on. UI freezes is another top concern for us. And by that, I mean something like the spinning beach ball on the Mac, right? So this happens when the UI thread is busy waiting on a slow call. So To find these, what we're doing is, if the UI thread is not responding for a few seconds, again, we will grab a whole thread dump and upload it to our server, and then we can put it in this dashboard. So here's an example. When I grabbed this, the top freeze was on average 14 seconds long, and we have over 50,000 reports of that. Right? So what we can do now is multiply those two numbers together, sort them, and then we can prioritize which UI freezes are causing the most total wait time for our usage population. So here's a little animation of one of our fixes. This is editing an XML file with data binding. This used to be extremely slow, and we fixed that, among with many other freezes. And we're not just spot fixing the UI freezes. We are doing a lot of work to prevent regressions in this area. So here are two examples. First of all, we modified Android Lint to run on Android Studio's codebase, which is not an Android app. And so we have static analysis, which looks for common causes of freezes. We also built a JVM agent, which we are including in our UI test suite. So whenever the UI thread is accessing a network call, we fail the test. So this is a bit like strict mode in Android. Next, let's talk about memory problems. And by now, you can probably spot a trend. We have a dashboard. So whenever the IDE runs out of memory, we grab some statistics about the heap and send it to our server. And there are two reasons why Studio can run out of memory. The first one is that Studio requires a lot of it. We model all your code, all your resources, and so if you have a massive project, it might not fit. But what if you have 32 gigabytes of RAM? That should be enough, right? Well, it turns out that when Studio runs on the JVM, its heap size is limited to 1.2 gigabytes. It does not automatically resize itself. That's just not how the JVM works. So even on a 32 gigabyte system, Studio only gets to use a tiny fraction of that RAM. Now, why did we pick 1.2? We were afraid to make it bigger because in that case, Studio won't even start on a low-end machine. And we're afraid to make it smaller because, well, then you can't even load a regular-sized project. So a pro tip is that you can actually change the size of the heap to give Studio more memory, where it'll run faster. But again, we know from analytics that almost none of you do. 99% of our users are running with 1.2 gigabyte heap size. So that's why, in 3.5, we look at your available RAM as well as your project size, and we make specific recommendations. And you can just click on the Save and Restart action here to accept our suggestion. Or you can open up the new Memory Settings dialog, where you can tweak to your heart's content. You can also set the heap sizes for the Gradle daemon and the Kotlin daemon as well. And of course, we base these recommendations, again, on data from analytics. We've created a model where we are doing some correlation between the heap size and the file count and the module count and things like that. But what if there's a memory leak? In that case, no heap size will ever be big enough. It will run out of memory eventually. So it's been a top priority to fix that, but the dashboard only has high-level statistics when someone runs out of memory. How do we actually track down the culprit? And we built a really cool mechanism for that. So if we can look at your heap, we can find the leaks. But obviously, we're not going to ask you to send your whole heaps to us because A, they're massive, and B, they contain a lot of personal information. Think about it. Your source editor has some of your source files in it. That's in the heap, right? So we don't want the heap. So what we do instead is if Studio runs out of memory or is nearly running out of memory and it's not functional anymore, well, then we grab a heap dump and we store it on your machine. Then, next time we start Studio, we optionally run an analysis on that heap file, we generate a report, and then we delete the heap file. And so the report file does not have anything personal in it. It's just a plain text file, which lists likely leaks that we've found. Now, you can scroll through the whole thing and convince yourself there's nothing personal there, and hopefully you'll click the send button at the end to upload it to our servers. And so we ship this facility in 3.5 Canary, and it's been incredibly valuable. We have found tons of leaks that way that we have fixed. And actually, the first couple of leak reports we got had a big leak from a popular third-party plugin. And so we grabbed the details, and we sent it as a bug report to that plugin developer. And they let us know that they had heard about this leak for years, but had never tracked it down. But armed with our bug report, they fixed it within 24 hours. So having client-side leak analysis is incredibly valuable because it doesn't just find leaks in our code that we test and ship. It finds it in all the plugins you're using, so it brings the whole plugin ecosystem forward. So while reacting to leak reports is great, it's not awesome because that means that we've already shipped a leak and negatively affected many of you. So another thing we've done recently, which is really promising, is we've implemented a new test runner. This runs our tests in a special way iteratively, and it grabs heap snapshots between each run, and then it does some comparisons, and it can automatically find leaks. So this recently caught a massive memory leak. This is a real screenshot from our build server. It found this leak automatically, and it was a really tricky leak. So this would have shipped if we hadn't had this, but thankfully it was caught before it shipped. The last system health attribute I'll talk about is speed. So one sort of well-known secret to a better IDE performance is to disable plugins you're not using. And that's not a bad idea to begin with because it reduces UI clutter. If there's a version control system you're not using, why should it be in your version control menu? But you shouldn't have to do this for performance. So one particular problem area we found was the C++ plugin. In some cases, it would be doing work even in a non-C++ project. So what we did there was we added a bunch of fast exits if we can tell there's no C++ in the project, and that's been very effective. Of course, the #1 speed complaint we always get for Android Studio is the build system. And it has always been a top priority for us, even back in the Eclipse days. And I'm confident that next year it'll still be our top priority. So because of that, we obviously didn't stop working on build speed during Project Marble. And in fact, we have several big improvements. We made annotation processing in Kotlin incremental. We made 6 out of the top 10 used Android annotation processors incremental. There's actually a lot to cover on the build system, so I'm not going to spend time on it here. Instead, we have a whole separate talk later today. It's called What's New in the Android Build System. It's a great talk. You definitely don't want to miss it. A majority of our users are actually on Windows. And it turns out that there's a lot of unique issues on Windows with things like the file separator character. We recently fixed long path support, but performance is a particular concern. And the biggest impact by far is the virus checker. File writes are multiple times slower when a folder is being checked with the virus checker. So in our measurements, if you exclude the Studio and SDK folders and your project folders, some of these common operations you see here are 4 times faster in our measurements, and basically comparable to Linux performance. So what we're doing now is on startup, we have this new info card, which lets you know if your SDK folder and your project folder are not excluded by the virus checker. Now, this does not mean that you should go and blindly exclude these folders. You are running a virus checker for a reason. And you have to decide the right trade-off between performance and security. And you need to take extra precautions if you do exclude folders from the virus checker. But we hope that at least this notification will make your users, will make affected users aware of this issue and this opportunity. And finally, on CPU usage, the emulator. We got a lot of complaints that the emulator was spending a lot of CPU cycles when it's supposed to be idle. So you're in the editor, emulator's off to the side, yet somehow your fans are running. So we fixed many issues in this area, and I want to highlight 2 that I just found super interesting. So the first one is that, yes, indeed, when you're using the Play image, it was really busy because it turns out Google Play Services is running after startup, and it is busy updating things and optimizing apps, and of course, that was burning cycles. Now, how do we fix that? Because what we don't want is for the emulator to behave, for the system image to behave differently in the emulator versus on a real phone. So the team found a cool fix. They basically tell the system image, you're on battery. When the system image is on battery, it turns off most background services. So that was a neat fix, but that made the screensaver kick in more often and turn off the display. So we had to fix that as well. A second cool fix is that the system image was listening for the hot word. right? So on a phone, you can say OK. I'm not going to say the next word. But it turns out that actually worked in the emulator. And there's no hardware support for listening to the hot word there. So the CPU was busy listening for the hot word. That was expensive. And I think it's kind of cool that it worked, but that was not on purpose. So we fixed this by turning off the microphone by default. If your app needs it, you can turn it back on. So a big part of Project Marble was fixing system health. The second area we worked on was fixing features that aren't working so well. So we're calling that polish on the slide, but that might give you the wrong impression. This wasn't just getting out a little cloth and wiping off a smudge. This was fixing some dents and in some cases replacing whole parts. And I think the best example of that is Instant Run. So we have a new version of Instant Run. It's called Apply Changes. And from the outside, it looks like the same feature. It's fast incremental run. You can hot swap your code and resources into a running app. But this is a complete rewrite from the ground up. We deleted 50,000 lines of code from Instant Run. And I guess boo Instant Run, yeah? We've also limited it to work for Android Oreo and above. And that let us remove a bunch of hacks that we had added in Instant Run to work on Dalvik and older API levels. So now we're only using supported platform APIs to do things like update resources and to hot swap code. So before, we would rewrite all your bytecode up front. We would have to insert hooks into your bytecode to allow for later hot swapping. So that made clean builds much slower if you had Instant Run on. And worse, it would actually spend some of the method handles. You have a budget of 64,000 method handles, 65,000 method handles. And so some users would turn on Instant Run and they couldn't build anymore. Well, that is not an issue at all anymore. With Apply Changes, there's no cost. We don't modify your app in any way. The APK we push to the device is identical to what you would do without Apply Changes. And so now we use hot swap basically from the platform instrumentation. Another reason why Apply Changes is better is that it is stateless. We are no longer keeping track of what the build system has done so far, and that led to all kinds of trouble when you would do things on the local device, such as plugging in different devices. So Apply Changes is much more robust. We fixed many things that were broken in Instant Run, such as multiprocess apps, so definitely give it a shot. But best of all, many of the things that the team did for Apply Changes actually benefits all runs. There were big improvements to the deployment pipeline around signing and app installs. Another feature we reworked is Gradle Sync. So while we made it faster with something called single variant sync, our main focus was making it more reliable. Things like the indexing suspender had all kinds of issues that should be better now in 3.5 beta. We also tried to make fail sync more actionable. So the error message should be clearer. We should have more suggestions. And if you've been using Studio, you might have seen something like this screenshot, right, where the editor shows up with red symbols. There are several root causes for this problem, but I want to highlight one kind of fun one. So when you build with Gradle, it will cache all jar files that you have referenced in your projects under your home directory. All jar files you've ever referenced. So this is a cache that gets bigger and bigger and bigger. And so last year, Gradle introduced a really great new feature where they do automatic cleanup of your cache. So if a library hasn't been touched by Gradle in between 7 and 30 days, it'll be automatically cleaned up, which is nice. But in Studio, when you restart the IDE, for performance reasons, we don't actually do a real Gradle build. We typically just load a cached sync state from last time. So we would load a cached state pointing to libraries in your Gradle folder, which had since been cleaned up. So we didn't have tests for this. We didn't realize the implication of this new feature, but now we do, and it's been fixed along with many other issues. Yay. All right. So speaking of dependencies, when we switched to Gradle, we made dependency management really easy. All you have to say is, I depend on Recycle View, give it to me. And the build system will download it for you, and as we've just seen, clean it up eventually. But for some of you, this has created a big problem. you can't really bring your project on a USB stick anymore. You'll have your sources, but not your libraries. So if you're trying to bring your project to a disconnected computer, it just doesn't work. And there were other users who had problems with strict internet proxies, at their work site. And some of you might be temporarily without a network because you're flying to Google I/O. So in 3.5, we are trying to make this better. We're working on making all of our repositories downloadable. So in 3.5 beta, you can download our Gradle plugin with all of its recursive dependencies. You can also download maven.google.com, all the stable versions. And what you do then is you unzip these folders under your home directory. And then you drop this script into the Gradle init folder. Don't take notes. This is in the README for each one of these downloadable repositories. But the point is, when this script is there, you don't have to modify any of your project on the machine. You build, and if these dependencies are in your offline cache, offline folders, it'll just work. So this is super helpful if, like Google, your company has a policy where you don't want your build servers to be hitting the internet, downloading stuff, right? We check in pre-builds for all of our dependencies, and now you can easily do the same. We're also trying to improve project upgrades. So if you created a project in 3.1 and you open it in 3.3, you'd get a scary-looking warning like this one, saying that you have to fix your dependencies or your project will break soon. Well, this message is gone. We always want sync to succeed, and we will give you build advice later, where we give you advice for your code, right? So inspections, editor, underlines, and the project structure dialog. And for this specific example, we have a lint check and a quick fix to handle it. Data binding. So data binding was always a supported feature, and I'm going to put that in quotes, because it was riddled with problems. So you've already seen the animation earlier of the performance problems, but we also went and fixed a cluster of bugs, and we even added some feature-ish things to make things better. So we added some new lint checks to pinpoint common configuration problems. We added some code folding to make it easier to work with. So if you've been using data binding, please switch to 3.5. It's going to be better, I promise. So our focus in Project Marble was on the first two areas I've already outlined: system health and fixing broken features. But we also assigned engineers to work on some top priority bugs and some top voted bugs. So when I pulled the stats a few weeks ago, we had fixed over 400 bugs. And this is beta, so I think by the time we hit stable, the number's going to be even higher. And that's not all, right? So due to time constraints, I can't actually cover everything we've done for Project Marble, so I'll just list quickly a few more. In the layout editor, we fixed a bunch of usability problems. In the build output window, we worked on our error parsers and the UI to make it do a much better job pinpointing what the build problem is and why the build failed. The 3.5 download is actually 300 megabytes smaller than 3.4. We worked to make lint CI faster, and so on. So to sum up, Project Marble was a really large investment for us. We dug into your top complaints, and I hope that you'll notice a big improvement when you switch to 3.5. And the last thing I want to say is that we do know that we are not done. We have not reached inbox 0 for our bug tracker, not even close. But we built a lot of infrastructure to catch problems, and we built these dashboards where we can monitor the health of Studio out in the field if you please opt into analytics, so that when we start landing features again, we'll hopefully hold the bar high. And with that, I'm going to turn it back over to Jamal.
Thanks, Tor. So as you can tell, we put a ton of work into Project Marble. And we encourage you to update to Android Studio 3.5 beta today to take advantage of all these updates from Project Marble. Now, speaking of updates, we recently did a survey with many of you about the upgrade process. And from the data, we found that a lot of people update Android Studio and Gradle at the same time. Now, this was required a couple years ago for features like Instant Run. But as of today, you can actually upgrade your Gradle plugin and Studio separately. And as you heard from Tor, we're making great strides in making the project upgrade experience easier. But we understand it takes a little extra time to upgrade your Gradle files. So from an IDE perspective, you should always run the latest version of Android Studio, and you can upgrade your project Gradle files when you are ready. Just like choosing your Android X version, keeping Gradle up to date gives you new features, performance improvements, and correctness benefits, but we give you the choice. With this version flexibility, this allows you and your team to use any version of Android Studio, stable, beta, canary, and as long as you're using the same version of a stable Gradle plugin, you have this flexibility. OK, so far we talked about a number of updates from stable to Project Marble, and you heard that our focus is on Project Marble and quality. However, I'm now going to give you a sneak peek of a few projects we started before Project Marble that we're going to get back to later on this year. OK, let's switch over to the demo. OK, so let's say we wanted to do some last-minute validation and checks on the Google I/O app. So like many of your apps, these apps can be quite complex. You can have a ton of resources, a ton of Java and Kotlin files. And many times it's hard to understand what's going on here without really digging into the source code. So one way you can validate this is just to run the app. So in this case, I have the I/O app here running on the Android emulator. And the first thing I want to check is foldable support. So with Android Studio 3.5, we now allow you to create a foldable version of your app. So things look pretty good. Looks like we have 4 columns of content. That looks pretty good on this instance. And here in the toolbar, we have this new icon called Fold. I'll fold it up. And then we get the new context of the new app. So things look pretty good here on the Android emulator for foldables. The next thing I want to check out is dark theme. So as you know, Android Q has an operating system level support for dark theme. But you can also control it in your app as well. So for the Google I/O app, I can go to the menu, go to settings here, and we have this new choose theme option. So what I'm looking for specifically is making sure I have that nice blue accent color in both dark and light theme. Let me choose theme here. Let me go to dark. Look, there's some issue, right? It looks like these switches are red, and that's not what I want. So to help diagnose this, in a future version of Android Studio, we're going to help you have a new version of the layout inspector. So if you're not familiar, the layout inspector is a way for you to look at the hierarchy of your app and see what's going on. So on the left-hand side has a view tree, hierarchy tree, and then on the right-hand side has a nice set of properties that you can click on. So in our case, we're looking at a number of different attributes. We added two new features to this layout inspector. So number one, if you had some issues with elevation, we added this cool new feature that allows you to look at the various levels of your application, which is pretty cool. But in our case, it looks like we're really going to focus on an issue in the actual switch colors. So let me just update this up here, OK? And let me click on this switch. And what's different about this is that it looks like there's some issue here with my switch material, OK? And here's a property for this. So what's different about this layout inspector with this new one is I can go from this layout inspector directly to the source code. So let me show you that. So let me hide this panel here. I just highlight the attribute. I just press Command-B, and boom. Right here on the left-hand side is now the source code that defined this attribute. Now, as you saw in that example, there was an issue with the theme. So let me go to the styling and do another Control-B, Command-B again, and go over to the styles. And it looks like we have two different styles, one that's a regular one and one that's a night one. So let me go to the night one here. All right, and I see here's the issue. It looks like someone had left a to-do to check on accessibility colors. So let me just comment those out real quick and see if that fixes the problem for me. So what I'm going to do here is click on the Apply Changes button. So as Tor mentioned to you earlier, this is a quick way to get quick fixes to the device without doing a full build on the device. OK, so back to the emulator. It's running red, it's blue, and it's fixed. That fixes the problem for us. And then to validate it on the layout inspector, let me just refresh the layout inspector, and boom, everything's good. So that is layout inspection. All right, the next thing I want to talk about is around resources. So, and I know for many of you, you have a lot of resources in your app projects. And the problem today is that if you want to understand what these assets are, you have to double-click on all of these assets, which is not that great. So what we added in Android Studio 3.4 is a new resource manager. So by the module type, actually now I can see visualizations of all the different assets, both in a list view and a grid view, and see how they all work and visualize them. And of course, if you had a bitmap, for instance, I can look at the bitmap, drill into the assets, and see all the various densities of my application. So one other pain point we're addressing is that many times you have a design team giving you updates to your application. Many times, let's say, a bulk file of SVG files. So in the past, you would have to individually update each SVG file and convert them to a vector drawable. We've solved that problem. So now if you click on this plus button here, you can go to Import Drawables. And here I have a folder of SVG assets. So let me go to this parent folder, and we just select the folder here and import this entire folder. And boom. And here we have this asset wizard that allows you to import all these assets. It does a couple different things. It checks for syntax of all the file assets. So for example, here it looks like we have the extra import asset here. So this one is an extra import, so we can actually remove this one. And it looks like we can also have a syntax error here, so we can actually make this from a uppercase G to lowercase g. And I press import, and boom. Here are all the assets converted from SVG over to vector drawable in one click. Now, another great thing about this is the panel is actually pretty interactive. So actually, I can drag and drop these assets onto any arbitrary XML file and see it visualized here as well. Now, let's say if you actually want to edit these files in XML, no problem. All I got to do is go back to the XML view of this application, go back to my assets. I can highlight an asset, move it right over to the XML attribute I want to update, drop it on there, it updates that, and there's the asset updated. The asset updated in real time. There you go. All right, the last one I'll talk about in this version is an update to the project structure dialog box. So this is for people who do not like editing Gradle files. So what you can see here is a list of all your dependencies and modules. And what's pretty cool about this is I can click on all the different modules, see all the resolved dependencies, and find any conflicts. And lastly, we have a suggestions panel. So if there's any sort of updates or any sort of conflicts, we have it all consolidated into one view. And so with a few clicks, I can update my Gradle file without ever having to update and manually edit my build.gradle file. So pretty cool. So next thing I want to talk about is motion layout. So motion layout is actually reaching beta status today, this week. But motion layout is a pretty cool feature if you have not used it. Basically, it builds on top of constraint layout. And motion layout allows you to have motion and move elements on a screen. And it contains two components. One, you have this motion layout file that describes how all the elements are described in a layout. The next file you have is called a scene file. And the scene file describes how all the elements move across the screen over time. Now, it's not too difficult to edit these files in XML, but it's not the simplest thing. So what we're working on, after Project Marble, is an editor for this. So here's my app that I'm working on. And if I can click on one of the components in the tree here, we now open up a new timeline view. And so what's cool about this is I can see both my start state, my end state, but also I can scrub through all the various states of the animation and play them back and forth to see how the animation is going to work over time. So pretty cool. And so the last thing I'm going to talk about is around Jetpack Compose. So as you heard yesterday, we just launched an AOSP, an early access preview of Compose. And what this is doing is actually kind of combining the best of kind of reactive programming in Kotlin. So instead of having a separate XML file and a Kotlin file, we're putting it all together in here. So I'm just going to walk you through how this code is structured. So for instance, I'm creating this card here on the right-hand side. I have all my attributes of my padding. I have my rows. I can put the text files right in here. And so all this is happening all inside one file inside of this compose function. And of course, you can run this inside the emulator. So we invite you to try this out. we have a special version of Android Studio that's available in the Android open source project that's specifically designed for this purpose. So please check it out afterwards in your leisure. And with that, let's go back to slides. All right, so I didn't have time to demo everything, but another cool update is on Chrome OS version 75 on high-end x86 Chromebooks. We have official support for Android Studio 3.5. So what's cool about this update, it also includes USB debugging support and a Chrome OS installer. Another update you don't want to miss is a new emulator with support for the embedded Android Automotive. All right, so we couldn't talk about everything about Android Studio and Project Marble today, so we invite you to see a couple other sessions as well. So yesterday, there was a talk on the Android emulator. You should check that out as well. This morning, we had a discussion around design tools this morning. Later on, I have a deep dive session on the constraint layout. And also a nice tips and tricks session coming up on Android Studio you should not miss as well. Again, we are excited to launch Android Studio 3.5 in beta for you to download today. It's the culmination of all the work inside of Project Marble. Even with the new infrastructure and dashboards in place, quality is definitely not done. But we hope you enjoy this release, which has less features, but is focused more on the fundamentals. OK, that's it. Thanks for watching our session on Android DevTools.